welcome back. This will be the last video related to matrices. And here we are going to look at 0, 1 matrices and powers of these matrices. We also define some other terms related to matrices and specifically 0, 1 matrices. Now, what is a 0, 1 matrix? Now, the name itself already explains it. It says that this is a matrix which only contains zeros and ones. And basically, this is something that people are using or trying to find when they're calculating, for example, linear programming problems using the simplex methods. Then we are using matrix calculations. And linear programming problems are very important to resolve using computers, of course. Now, we look at discrete structures that can be, let's say, represented by 0, 1 matrices, and the algorithms that are using these are in fact based on Boolean logic. And we have the Boolean operators and or, which can be used here as follows. When we look at B1 and B2, this is equal to 1 if B1 is equal to B2 and is equal to 1. If one of them is not equal to 1 or both are 0, then the output is 0. On the other hand, we have the OR operator. It's equal to if one of those two is equal to 0 or both of them, and 0 otherwise. We've seen this before when we were defining those operators earlier in the course. Now we can define what we call the join and the meet and the Boolean product of 0, 1 matrices. Now we consider the following information. Let's consider two matrices A and B, which are M times N0 matrices. The join of A and B is the 0, 1 matrix with the ijth entry AY or Bij, and the join of B and A is noted as A or B. We can also define the meet of A and B. This is the 0, 1 matrix where the ijth entry is equal to Aij or Bij, and the join of A is noted as A or B. Now we can define the Boolean product on matrices. So we have the 0, 1 matrices. Now we have to be sure that they can be multiplied. So A with the parameters Aij, let's consider it to be an M times K matrix, and B with elements Bij, a K times N matrix. So we can multiply A with B, and we call it the Boolean product of A and B, or we write it as a Boolean operator B, which is M times N0, 1 matrix, with the ijth entry is equal to Cij, and Cij is like the multiplication that we did before, but now we're going to use the and the or operator. So for Cij, we can say that is AI1 and B1j, or AI2 and B2j, or at the end, AIK and BKJ. So it's like the multiplication, but instead of using the multiplication, we use the AND operator, and the OR operator is like the plus operator. Basically, that's what we're doing. We're doing the same thing like the multiplications, but we are changing. In fact, we're replacing the multiplication with the and the addition with the OR operator. Let's have a look at some exercises to show you how this works. It will explain a lot more than just a formula. Let's have a look at the following 0, 1 matrices. So we have A 1 0 1, 0 1 0, 0 1 0, 1 1, 0. Now, when we look at those, we can look at the join. So we join A with B. So we look at A or B, which we can replace by 1 or 0, 0 or 1, 0 or 1, 1 or 1, 1 or 0, and 0 or 0. So we can basically replace this. When we look at the first column, we have 1 or 0, 0 or 1, 1 or 0. Those are all equal to 1. Then we have the 0 or 1, 1 or 1, and 0 or 0. The first two are equal to 1, and the last one is 0. So basically, the join is in fact, we can now continue with the meet of A and B. So we have A and B. And now we are, instead of using the OR operator, we're using the AND operator. And we find now 1 and 0, 0 and 1, 1 and 0. Since all of them only have one element which is equal to 1, all three will be equal to 0. For the second column, we have 0 and 1, 1 and 1, and 0 and 0. The first and the third element are equal to 0, and the middle element is equal to 1. So we find here that the meet of A and B is 0, 0, 0, 0, 1, 0. So basically what we found here are those results. Now let's have a look at the Boolean product, and we look at 2, 0, 1 matrices. We have A equal 1, 0, 1, so 3 rows, 2 columns, 3 times 2, and B, which is a 2 times 3, 1, 0, 1, 1, 0, and 1. And now we have to use or apply the Boolean product. So we multiply A with B, which is possible because we have a 3 times 2 multiplied or Boolean product with a 2 times 3 matrix. Now, when we look at this here, we can start doing the calculations step by step. The first element that I find is the Boolean product for cell 1, 1. And we have 1 and 1, or 0 and 0. So we find this first element here. We can now do this for all the other elements too. Now you can stop the presentation here and complete the matrix. Once you've finished, you can come back and we will see that you find the same results. So now we have to do the multiplication. We have to find the other terms here. When you did the multiplication with the Boolean product, you find finally this solution. So for the second part, we have 1 and 1, or 0 and 1. And for the third one, we have 1 and 0, 0 and 1. So now we can in fact translate these into the next step. And 1 and 1 is 1, or 0 and 0, that is 0. So we find here for this first element, the expression that we have there can be replaced by 1 or 0. For the second column, the first row, we have 1 or 0. The third one, we have 0 or 0. We have 0 or 0, 0 or 1, 0 or 1, 1 or 0, 1 or 0, 0 or 1. And we can find this in this new matrix. Now we have to continue here, and now it's quite easy because we have the OR operator. So 1 or 0 is 1, 0 or 0 is 0, 1 or 0 is 1. And finally, we find the matrix 1, 0, 1, 1, 1, 1, 0, 1, 0. We can also like we did in the previous matrices, in the general matrices, calculate the Boolean power. And we can apply this also on 0, 1 matrices, so we can calculate the power of 0, 1 matrices. Now, we have a 0, 1 matrix, and we have a p, a positive integer, which is the pth Boolean power of A. And it's the Boolean product of p factors of A, and it is denoted as A to the power of p. So within the square brackets to indicate that is the power of the 0, 1 matrix. We can also write it as the Boolean product p times of A with A. Now let's consider a matrix A, which is a 3 times 3 square 0, 1 matrix, and we want to calculate A to the power n for all positive integers. Now when we do this, we have A times A like we did before, so we can use the previous formulas, and we find that the result is 1, 0, 1, 1, 0, 0, 0, 1, 1. So basically we multiplied here 0 and 0, or 0 and 1, or 1 and 1, which gives me 0 or 0 or 1, which gives me 1. Now we can continue this, and let's have a look now at the step-by-step calculation of this matrix, of this result. So first of all, we start with the first element. So we have the Boolean power, the square, Boolean square of A is the Boolean product of A with itself, and we find A11 to the square, and so on. We find all those 9 parameters that we have to calculate. Now what we first can write for A square 1, 1 is 0 and 0, or 0 and 1, or 1 and 1. The next thing we can do is to get the same thing for the second element. So we find 1 and 1, we find 1 and 0, 0 and 1, and 0 and 1. And the last element in this column is 1 and 0, 1 and 1, and 0 and 1. And now we can calculate for those. We can apply the operation between the bracket first. So we have 0 or 0 or 1. We have 0 or 0 or 0. And we have 0, 1 or 0. And basically get the first elements of the first column, which gives us 1, 0, 1. Now we can do this for all the other columns. You can verify if your calculations are correct and see where you got your error. So when we do it for the second column, we find 1, 0, 0. And for the last column, we find in fact the elements 0, 1, 1. And that's what we finished to do here. We calculated in detail the second power of the matrix A. Now what we still have to do is to calculate the other powers up to n. We already know the first one, so we finished A to the square, we found the result, and now we can multiply A, the Boolean product, with A to the square. So we have 0, 1, 1, 0, 0, 1, 1, 0, 0, Boolean product with A to the square, which is 1, 0, 1, 1, 0, 0, 0, 1, 1. And you can calculate this on your own and see if the numbers are correct and compare your result with the result here on this slide. We do the same for A to the fourth power, so we do again the Boolean product of A with the third power of A, and we find a new 1, 0 matrix, which is 1, 1, 1, 1, 0, 1, 1, 1, 1. And now something special happens when we take the fifth power. We find that the result is a special matrix which only contains ones. 1, 1, 1 everywhere. So basically, when we are going to include or to increase the number of powers, whatever power we select, we will always get back to 1, 1, 1, to the same matrix. So once we have 5 up to whatever power we want, the result is all the same. So basically, this was the last video in the series about matrices. We've seen a lot of things about matrices, and it's also the final part of this chapter. The next chapter will be about algorithms. You're doing a great job, and I'm looking forward to seeing you in our next video. Thank you, and bye-bye.